So the question says, draw a Lewis dot diagram for a molecule of CH4 and for a molecule of CO2. Sorry, the bell went off. So CH4 and CO2. You want to draw two separate Lewis dot diagrams here. So in order to draw a Lewis dot diagram for a particular molecule, you need to know how many valence electrons there are in each of the elements in that molecule. So let's first look at CH4. CH4. Now we have two elements here. We have carbon and we have hydrogen. Let's take a look at our reference table and see let's see how many valence electrons carbon has. If we look, the last number in the electron configuration, whoa, that's way too big, tells us how many valence electrons we have. So here we see that carbon has 4 valence electrons. So let's just draw that out. Remember, when you're drawing Lewis structures, you want to draw the valence electrons as little dots around your element. So we have 4 valence electrons, so let's draw the 4 dots. If we look at hydrogen, we see hydrogen only has 1 valence electron. Now the ultimate goal for every single element, except for few exceptions like hydrogen, is to get 8 valence electrons. You want 8 dots. Now the way we can do that for CH4 is we can put one of these hydrogens on each side of this molecule, on each side of this carbon, excuse me. Let's take this hydrogen, and let's put it right here. Well, now we have 2 valence electrons right here, right? 2 electrons for carbon right here. If we do that, if we use up all 4 of our hydrogens, and we do that, we can wind up getting a Lewis structure that looks like this. Right? Each one of those hydrogens is giving one of its electrons to that carbon. Well, it's not really giving it, it's more like sharing it with it. So now that carbon is happy. It has its 8 valence electrons, but what we don't do is we don't leave it as the dots. Anytime you have 2 dots, 2 electrons, like right here, or right here, right here, or right here, you represent them with a line. So, for example, it's going to look like this in the end. Those 2 electrons on top, and those 2 on the right, and those 2 on the bottom, and those 2 on the left are all represented by a line. And again, we just put the hydrogen there. And that is our Lewis structure for CH4. Now let's do it for CO2. CO2. Carbon dioxide. So again, the first thing we do is we find out how many valence electrons each element has. So let's see carbon first. We already know from the last part that carbon has 4 valence electrons. 1, 2, 3, and 4. We also know that oxygen, if we look at the reference table, the periodic table, excuse me, it's kind of small on the screen, but if you zoom in, you'll see that oxygen has 2-6 for its electron configuration. So 6, therefore, the last number, is your number of valence electrons. So let's draw oxygen. We have 1, 2, 3, 4, 5, 6 valence electrons on that. So how are we going to bond this so that everything has its 8 valence electrons, right? We have 2 oxygens and 1 carbon. 1, 2, 3, 4, 5, 6. But what we can do is we can move one of these electrons right here to this side. And we can move one of these electrons right here to, let's say, like this side. Because it's impossible to share in 2 places at once, right? We can't have this carbon that we want to attach share with this electron right here and this one right here at the same time. It's not possible. So we move those electrons over to one side to make it possible to share 2 at once. Let's do the same thing for carbon. All right, let's move this over to here. And let's say we move this one over to here. Now, let's take this oxygen, put it right here, And let's take this oxygen and put it right here. Well, now this carbon has 8 electrons outside of it. It has 4 over here and 4 over here. Now remember, the lines represent 2 electrons. So let's draw 2 lines because we have 4 electrons. So 2 lines and 2 lines. And that's what your carbon dioxide molecule is going to look like. It's not necessarily going to be bent like this. I just ran out of space. But that's what it's going to look like. Let's actually do one more. Oh, and by the way, this is called a double bond. When you have 2 lines like that instead of the 1 like this, that's called a double bond. Let's do one more. Let's look at one that doesn't involve carbon. Let's look at one that's probably closer to what you'll see on your final. Let's say NH3. Right, ammonia. So if you look, nitrogen has 5 valence electrons. I'm not going to zoom it in, but if you look at, actually, you know what, I will zoom it in, just in case you get confused. If you look, nitrogen has those 5 valence electrons. Right, which means it has 5 electrons in the outermost shell. So let's draw those 5. 1, 2, 3, 4, 5. And then let's draw those hydrogens. We have 3 hydrogens. Right, and each one of those hydrogens has 1 valence electron. Well, this one's really not too bad. Let's take this hydrogen, put it right here. Let's take this hydrogen, put it right here. Let's take this hydrogen, and let's put it right here. I gotta move this electron though. Well, now nitrogen is happy. It has its octet completed. Right? That one wasn't really too difficult. Right? That's more of the line of what you're going to see on like a Regents style question. They don't typically ask you to do ones that involve double bonds. Right? You're really going to be doing more ones like this. Now what we have to do is replace those bonded electrons with the lines. Right? Remember, each line represents 2 electrons. Now the thing is, those 2 electrons on top, you might be thinking, oh, I have to replace those 2 at the top with a line. No, you don't have to do that. Right? The only time you replace them with a line is if it is bonded with another atom. So in this case, that is your Lewis structure for ammonia.